So next is this disk scheduling algorithms. Firstly, we consider how long it takes to read or write a disk block. The time required is determined by three factors. Seek time. It is the time to move the arm to a proper cylinder. Rotational delay. The time for proper sector to rotate under the head. And actual data transfer time. For most of the disk, what happens? The seek time is always greater than the rotational delay and the actual data transfer time. Hence, by minimizing the mean seek time, it is possible to enhance the system performance significantly. But if the processing of the request by the disk driver is FCFS, then you cannot optimize the seek time. So what can you do? We will do a yet another approach. In case of heavily loaded disk, when the arm is seeking one request, the other disk request may be produced by another processor. Several disk drivers keep a table which is indexed by cylindrical number. In this, all the pending requests for each cylinder chained together in a linked list headed by the table entries up. So FCFS, first come first serve. The first come first serve algorithm is the simplest scheduling algorithm. This algorithm is basically fair. This algorithm does not offer fastest service. Why? Because suppose you have 16, then you have 122, then you have 85, then you have 15. So what it will do? First it will cater to 16, then 122, then 85, and then 15. So 15 and 16, though they are close to each other, then 2. It will not cater to 15. So it is not a fastest service. Also, swing is larger. So from 16 going to 15, rather than going to 15, we are going to 122. So we say that the swing is a larger swing. So more time is taken. Hence it is not that efficient. Shortest seek time faster. This algorithm services all the requests near to the current head position before moving to the head far away to the service other requester. So if 16 and 15 both are present along with 122 and 85, and if I say that we have to start from position 16, then first it will cater 15. It will not cater 122 and 85. So it will cater the one which is nearer to the current head position before moving to the head far away to the service other requester. The SSTF algorithm chooses the request with minimum seek time from the current head position. So 16 and 15, minimum seek time is there. So it will choose 15 rather than choosing 122 and 85. As the seek time increases with the number of cylinder passes through the head, STF chooses the awaiting request closer to the current head position. That means if it is starting from 16, it will go to 15 first. After going to 15, it will go to 85 and then it will go to 122. So between 15 and 85, the seek time is larger. Seek time is more. But what does it do? It chooses the next awaiting request closer to the current head position. So closer to 15 between 85 and 122 is 85. Scan scheduling algorithm. The movement of the disk arm in this algorithm is from one end of the disk and it goes to the direction of the other end. While doing so, it serves request as it arrives at each cylinder until it arrives at the other end of the disk. After reaching at the other end, the direction of the head movement gets reversed and servicing continues. The head repeatedly scans back and forward across the disk. The disk arm acts like an elevator in the building. Initially, it serves all the requests towards the down, and then comes to the and then on the way. Therefore, the scan algorithm is also called as the elevator algorithm. So, for example, 16, 122, 85, and 15. Starting position is 16. So, suppose there are 150 total movements. From 16 it will go to 85, it will go to 122, then it will go to the end position, that is 150. 149. 0 to 149 is 150 head positions, and from 149 it will come back to 15. C-scan. C-scan is called circular scan scheduling, and it is a variation of scan. It offers a more uniform wait time. Just like scan, and C-scan moves the head from one end of the disk to another, serving requests along the way. When the head arrives at the other end, however, it is straight away returns to the beginning of the disk without serving any request to the return trip. So once the head goes to the last position, that is 149, it will come to the beginning of the disk without serving the other positions. Look, above two algorithms, scan and C-scan, move the disk arm across the full width of the disk. That means they go till the end. If the number of movements are 150, then till 149 it will go. But in case of look, it does not go till 149. It will go to the last position of the final request. Normally the arm goes only as far as the final request in each direction. Then it reverses the direction straight away without going all the way to the end.